Hello students, this is Professor S.H. Bhandaru from CSMSS College of Polytechnic, Kanchanwadi, Aurangabad, Maharashtra. In the previous lecture we had studied about MOSFET, that is D MOSFET, depletion type, and in this lecture we will be continuing with the next part, that is E type MOSFET, that is enhancement type MOSFET. So first we will see the construction of N channel E MOSFET. So previously we had seen that in D MOSFET there was the channel present, but in this case the difference is there will be no channel present. So how it will work we will see further. As you can see in the construction of N channel E MOSFET, there are three terminals, again drain, source and substrate. Now as we can see, it has P type substrate into which two N regions are diffused. A metal contact is attached to P substrate and a terminal is taken out called as substrate SS. Two metal contacts are directly attached to two N regions and terminals are taken out called as drain and source terminals. A metal contact is kept isolated from P substrate by a thin layer of silicon dioxide and a terminal is taken out called as gate. As compared to D MOSFET, in E MOSFET the channel is absent, as you can see it clearly in the figure. Now let us see the working. In the working we can explain it into two parts, that is when VGS is equal to 0, that is gate to source voltage applied will be 0, and in the second part we will be seeing the operation with positive VGS, that is gate to source voltage will be positive. So let us see what happens when gate to source voltage applied is 0. Now when VGS is made 0, that is by connecting gate and source and substrate terminals together to the ground terminal. So a positive voltage source is applied between drain and source, as you can see in the figure. So as there is no channel available for conduction, hence drain current becomes almost 0, that is you can say practically current is 0 and it is in the off state. That is when VGS is equal to 0, ID is 0, that is drain current is 0. Now in the next part, when positive voltage is applied between gate and source, what will happen? Let us see. The positive potential is applied at the gate, replaces the holes and attracts the electrons from P substrate, as you can see in the figure. Now this results into the formation of a depletion region near SiO2 layer. As we go on increasing VGS, more and more electrons are attracted near the SiO2 layer. Now at a particular value, this electron concentration increases to such an extent that it induces a channel which joins two diffused N regions. As the channel gets induced, drain current starts to flow through the MOSFET, and thus the MOSFET is said to be in the conducting state. As you can see in the figure, the electrons are moving, so the drain current is now conducting. Now let us see the advantages. Now what are the advantages? Now advantages will indicate how it is better than the D MOSFET. Now as we had seen in the previous lecture, the advantages of D MOSFET were explained. Now we will see the advantages of E MOSFET. Here these MOSFETs provide greater efficiency while operating at lower voltages. Second, absence of the gate current results in high input impedance, producing high switching speeds. So this is the greatest advantage of E MOSFET. And third, they operate at low power and draws no current. So these are the three major advantages of the MOSFET. Now if you have any doubts, please let me know in the comment section, and we'll continue with the next part in the next lecture, that is the drain characteristics and the transfer characteristics. Thank you so much.